Hello guys, what's up? My name is Aaron and I'm here back again for you with a Kerbal space program video with the mod Principia. I need to say I really love this mod because I'm so interested in space flight, and this mod represents orbital mechanics way better than stock Kerbal space program. And because you guys seem to like my last video about how to get to the L4 point, I did another video where you gonna watch how I am flying to the Lagrange point 2. I put again the same probe together like before, like in the first video. It's again the simple probe with just a probe core, some batteries, solar panels, and a lot of fuel. Really a lot of fuel. I think it's nearly 3000 of delta V. I think it's like that. So you could basically fly to a lot of planets with it, but we are just gonna stay inside the Kerbal, no, not the Kerbal solar system, the Kerbal system. I wanted to say solar system. Okay, so we are launching again. Nothing special. On the left side I put up the Ferrum Aerospace research panel. I really like this mod too because it's more realistic. I like when it's realistic. And what I was watching for was my dynamic pressure, because my dynamic pressure and the drag and all the forces that are shown there show me how much I can offset my thrust without losing control of my rocket. So we are pretty much up 35,000 meters. And you can see the dynamic pressure went down pretty far. Okay, just accelerating a bit to match orbital velocity. We're gonna do the same orbital insertion maneuver like before, going up to an apoapsis of about 3000 kilometers, and then circularizing our orbit. And after this circularization burn, we will head off to the moon. Okay, pretty much up here. 60,000 meters, perhaps of 2,000 kilometers, and yeah, it went out to be 3,500 kilometers. Stage separation. There's our little probe, like you know it. Nothing special, with tiny RCS ports on it. I think these RCS ports are way too powerful, but we will see later, because we are going to the L2 point, and the L2 point is one of the unstable points. As I told you, L1, L2 and L3 points are all unstable. That means you need course corrections to stay there. You can orbit these points for a few times, but then you will drift off. That's because of the axis of stabilizations. Actually, the L2 point, for example, and the L3 point as well, and I think also the L3 point, they are all stabilized in the axis. How do you call it? Or let me say it like this. They are unstable in the axis of the body and Kerbal. So in the axis of the moon and Kerbal, they are unstable. This means you can orbit this point from left to right and left to right without any problems. But once you drift out too much to the direction of the moon or Kerbal, the gravity will pull you, and you will get pulled back to this planet or the moon. Okay, just doing the same thing, changing my reference frame to the moon, and I've chosen again a rotating reference frame. Okay, because with a non-rotating reference frame, this means the reference frame is frozen. The direction of the reference frame is frozen. It moves with the moon, but it's frozen. It doesn't rotate with it. And it's much easier to see. Oh, look at this. I'm not really sure, but it looks like this is about where the L5 point is. Well, okay, we can look at this in the next in another episode. But first of all, we plot our trajectory with the help of the flight planner. I'm always setting the plan length in the top of the flight planner to something about 50 days. Look at this orbit. That's when you change the reference frames. That's how it looks like. You can see the reference frame is not selecting. And in reference to Kerbal, you can see it would be just a normal escape trajectory with the help of the gravity assist of the moon. Okay, what was I talking about? Yeah, right. I was talking about the plan length. Just set it to a couple of days, because the plan length gets kept. I don't know at which day exactly, but I think it's like 30 days, something like that. You can plot it much longer, but this amount of days is completely sufficient for most of your maneuvers. So I just take this one and move it all the way up the plan length, and then it should be all right. Okay, doing our little burn. Here we are coming closer. I actually missed my first burn because I was a bit lazy. This looks quite right. It's no problem when you don't match your planned flight plan perfectly. It's alright as long as you this the orbit that you want, and my orbit that I wanted was a close approach to the moon. It's like a slingshot maneuver. We're getting a lot of kinetic energy from the moon with this maneuver, and that's why we need to cancel some of this. I'm just setting maneuver node circa at the periapsis, and I'm gonna not. Why did I accelerate? No, I want to decelerate. And that's nearly it. Just decelerate a bit. And you will see when we hit the L2 point a bit more, you see how our orbit gets pulled to the other side, and there it is. You see this nearly straight line that has nearly the same curvature as the moon's orbit. That's the L2 point, and that's where we want to head to. Okay, I added another maneuver node. It's pretty easy. Just click on Add Maneuver, and you can move this one further apart and plot your maneuver from there on. And we just need to de-accelerate again a bit. It's like 7.252 meters per second. It's a really low speed, really less delta V we need. That's why I put on some RTS thrusters. Let me just see if I can get some other nice orbits, because I just like to play around with the flight planner to see what kind of strange orbit I can get. So you see how different these orbits are, and they're shifting to another side. That's because of the Earth's influence. The Earth is pulling us more and more over to the other side, while the moon is rotating around, orbiting around the Earth, or not Earth, the Kerbal. But let me see. This would be a hit. The moon, we would hit it. It looks quite funny. I love it when you see these orbits getting away from the moon or planet and suddenly turning around, slowing you down and doing these wonderful curves. I just love it. So more interesting than the stock Kerbal Space Program orbits. Okay, let us come back to our L2 maneuver. So we need to hit this point. Just eyeball it. I completely eyeballed it too. Just play around with the flight planner, and when you see this straight line, when you see that your orbit is doing this halo-like thing, then you're completely right. Then you hit the L2 point. Heading off to the moon. We are nearly there. I'm just doing it carefully because I don't want to overshoot it. Because if I overshoot it here, it will be much more difficult to hit this point. Okay, just putting down my thrust limiter. We'll see why in a few minutes. And heading off to the maneuver node. We need a small retrograde burn, about 10 meters per second. That's not much. It's really less delta V than you need for some other maneuvers. Okay, I'm doing the burn. And really carefully. Perfect, this looks just perfect. Okay, I'll take it like this. And we're heading off to the L2 point. What you see here, what you can see here is that we orbit this L2 point only one time, and then we drift off too much to one direction, and that's why we got pulled back to the moon. That's why this happens. We drift off too much in the direction of the axis between the moon and Kerbal. Okay, I'm positioning myself, and what you need to do to stay in this halo orbit, that's how it's called, you need to do course corrections. And my thrusters are way too powerful. 5%, let's see how this works. Still way too powerful. You see, the amount of thrust you need, it's a really low thrust, because you only need a couple of meters, no, not a couple of meters per second. It's like 0.05 meters per second. That are the delta V dimensions that you need to fine tune this orbit. Okay, I'm just going with this one. This looks good. Or can I get it a bit closer? This one looks nice. I'm loving it. I also put up the max history length in the Principia window. That's the yellow path you can see. That's your orbit you've done before. It's like tracking your path you've taken. You see this? The prediction of my orbit? We're nearly hitting the L1 point. You know what, guys? You know what? I'm really excited, and I want to do a simple transfer maneuver. I want to transfer over to the L1 point. Oh, I'm loving this mod. I'm loving it. Playing around with this. Okay, I think to do this we need to accelerate a bit more. Just putting up another flight plan. Okay, tangent plus. Yes, I think that's it. But let me try out some other directions. As I already told you, I often just eyeball it and play around with the flight planner to find my maneuvers. I'm not a rocket scientist or something like that. Actually, I'm studying engineering. I don't know how it's called in English. In German, it's called Flugzeugbau. That's the engineering of building planes. So it's not really spaceflight, but it's not far away from it. A lot of things you need in planes, you also need in space planes. Not space planes. What am I talking about? You also need in spacecrafts. So okay, let's plot this trajectory. Put another maneuver down here, and we need to de-accelerate, I think. So we can hit the L1 point. Same again, like with the L2 point. Play around until you see the straight line. Until you see your orbit getting bent around and doing this halo-like thing. And there it is. There it is. It's doing it. I'm loving it. A bit of fine-tuning. You can see how small adjustments I can do. It's less than 0.0001 meters per second that I need. It's such a low thrust that you can't really manage to do it perfectly with Kerbal Space Program engines and the limits of your keyboard and the reaction times. Okay, coming close to the periapsis. Don't want to overshoot it again, so I'm just taking it carefully. I'm coming closer and closer. Okay, 40 seconds. I'm still using the periapsis indicator of Kerbal Engineer, although it is using the stock orbits calculated by Kerbal Space Program. They are most of the times accurate enough. Okay, just doing my burn. See, the orbit is coming around, and that's already that's already our L1 point insertion. And I also put up the history length, so you can see this nice transition, these nice patterns drawn by our spacecraft, transferring from L2 point to L1 point. Trying to get it a bit closer, but that's good enough, guys. It's way easier when you do the course corrections when you are already in the L1 point. Bit of time warping here. We're going around and coming into this nearly straight line. And this orbit is called a halo orbit. Let me explain why, or why it has this shape. It has this shape because in the axis, I think it's perpendicular. That's the right word, yeah, it's perpendicular. The axis that is perpendicular to the Earth, Moon or Kerbal Moon axis. In this axis, your orbit is stabilized. That means when you go out to one of these directions, you can pull back towards the L1 point. But as I already said, when you go out too much in the direction of the Earth Moon axis, Kerbal Moon axis, you will get pulled off because there's no stabilization in this axis. That's why these points, the L1, L2 and L3 points, are called unstable points. Or no, it's called unstable points. While the L4 and L5 points are stable points, because they have this correction in all the three axes. And we just need some course corrections once we hit a few orbits, just to stay in there. It's always the same. When you're playing a career game, for example, and want to put out a communication satellite, I would recommend you using Kerbal alarm clock, plotting this maneuver with the flight planner, entering the time you get displayed there until your maneuver node, and just come back when Kerbal alarm clock tells you you need to do your course correction so you don't miss them. That's how you can put some communication satellites up there when you're playing with remote tech, for example. Okay, guys, that's our orbit. Let's do another course correction. I'm just eyeballing it. Auto wait firing, and there it is. There it is coming again. Very nice. This looks good. In the end of the orbit, I'm drifting away to the Earth. That's completely normal. Or you're drifting away to the Moon. Let's do some course corrections. But I love this shape of these orbits. They look so awesome. And actually, when you Google for L1 or L2 orbit, you can see pictures of real orbits which look exactly the same, or nearly exactly the same. You're just changing the frame of reference. That's how it looks like if it's a non-rotating frame. So you see, because of the non-rotating frame, you switch the side of the Moon. That's because the frame is non-rotating. So you are always facing inwards to the Earth. Or in reference to Kerbal, our orbit looks like this. We are orbiting the same speed as the Moon, but a bit closer to Earth. You know what, guys? These L points, L1, L2, L3, L4 and L5 are also possible with Minimus. But let me warn you, these orbits, the L orbits, the halo orbits about the L points of Minimus, look extremely... how do I tell it? They look really silly because they change a lot and get so much influenced by the Moon's gravity. It's awesome. But that's something for one of the next videos. So guys, I think that's it. I've shown you how you get into these orbits. You can try it by your own. And we see us hopefully in another video.